For this assignment, we will be conducting a case study on the Z-Design building by Amir Shiner, Amir Man. We will now showcase the IBS construction procedure in this physical model. The very first step of an IBS construction is, first, the site is excavated and leveled. Cast in situ footings are installed, followed by the construction of the column stumps and ground beam. In situ concrete slabs are built on the building site using formwork of rebbers with damp proofing layer. After the in situ foundation and ground floor slab are placed, the column are put in place in the exact same position as the RC stumps. The columns are designed to be pinned, partial or full moment resisting to meet structural requirements. The connections of column to pile cap are either pocketed or steel base plate joint. Columns are connected to each other by using concealed steel billet joint or exposed concrete corbel joint. Precast column with sizes ranging from 300mm to 400mm are used. We will now cast the precast beam into place. Beams are set on bearing pads on the column corbels. Steel angles are welded to metal plates cast into the beams and columns, and the joint is grounded solid. Precast beam with sizes ranging from 300mm to 400mm are used. Next, precast staircase is installed, following by placement of the precast bathroom pods. Then, precast wall panels are installed. After that, the cantilever beams are cast into place. Shim plates are placed at the edge of the staircase in order to position it correctly onto the precast beam. The concrete staircase is of grade 35 with a ratio of 1:3:5 and has 16mm as C-bars. The wall panels are set up piece by piece and having it secured by an L-shaped steel channel. Panels are connected together by using cement to fill up the gaps in between them. For the precast stairs, we are using the sizes from HC Precast Systems Sindiri and Berhad. Wall with sizes ranging from 600mm to 980mm are used. We are using cantilever beams provided by Pico Group. After all the precast wall panels are placed, the hollow core floor panels are placed on top of the L-beam or T-beam. After that, the cantilever beams are cast into place. Slabs are connected directly by bearing joint to the beams. The soffit of a hollow core slab is made from a steel mold. Not only that, they are designed to have effective shear key joint between adjacent slabs. The wire mesh are arranged 200mm vertically. The concrete is reinforced with a C-bars of 16mm in diameter for longitudinal members and 12mm in diameter for traverse members. Hollow core slab with lengths ranging from 2,400mm to 7,000mm are used. After the precast columns, beams, and floor slabs are in place, the precast bathroom pods are placed in their respective locations according to the plan to complete the floor slabs. The walls are 50mm thick with ceramic or marble tiles glued to the walls with a special adhesive, and the thickness of the floor is 100mm thick reinforced concrete slab. For the precast bathroom pods, we are using sizes available from East to Pritech. Steps of construction are repeated for the next 2 floors. The roof is fabricated on site after the superstructure is set up. Next, a layer of rock wall insulation followed by a layer of aluminum sheet are placed on top. The corrugated metal deck is then placed as a finishing layer. The main structure of the roof is a curved steel truss, and a small C-purlin is positioned above the truss by using an O-plate. We are using roof structures available from BlueScope Lissat. Lastly, railings of the balconies, doors and windows frame are fitted into their allocated space. Then, fill the jambs with mortar evenly up both sides. We are using doors and window sizes available from HC Precast. Railing posts are inserted to be firmly fixed to balcony structure with fixing plate, and handrail connector fits into top of post. The embodied energy for our building was calculated based on the sum of the number of units each component has before construction. Each component, such as the floor, wall, columns, beams and roof, were divided into different types. The embodied energy for each component types were calculated, and the sum of these components determined the total embodied energy of our apartment.